Happy day to my students and viewers. This is Nagarajan working as an assistant professor in the Department of Electrical and Electronics Engineering, working in MAM School of Engineering, accredited by NAC, approved by ACT New Delhi, affiliated to Anna University, Chennai. So in the previous videos, we discussed about the bioamplifiers, need for bioamplifiers. What are the amplifiers that were utilized in the biomedical instrumentation applications? And today, one of the part we are going to discuss is chopper amplifier. Okay. Right. So chopper amplifier. What is mean by chopper? First, we should know what is mean by chopper. Okay. Let me give a small example. When you are going to cut fruits or vegetables, what usually it is called as chopping of vegetables, chopping of fruits. Okay, and in which place we are doing this one? We are doing by placing the fruit or vegetables on a chopping board. Okay, chopping board, and the knife that we are using for the cutting purpose will be called as chopper. Keep in mind that will not be called as a knife or some other cutting device. It is called as chopper. Okay, so from this you can understand that chopper is cutting into pieces. Okay, so why we are cutting into pieces? We cannot eat the whole apple. Okay, so we must cut into pieces. Okay, mostly you will be using our teeth as a chopper. Okay, we never use some other objects to cut the fruits. Okay, so here that is chopper. Okay, cutting a full object or a full signal into small pieces. Okay, that is here it is mentioned. If you look at this diagram, okay, if you look at this diagram, you can able to understand that here 6 millivolt is a continuous voltage. Okay, that is given at the input, and here this is a chopper. Okay, that chopper is providing chopped 6 millivolt. Okay, so the output also we are getting the same. Okay, but here keep in mind the output, we can increase the output voltage or decrease the output voltage depending upon the time interval. Okay, depending upon the time interval. So here it is given that our input is 6 millivolt. Okay, our chopped input is also 6 millivolt, whereas our output, you just look at the output, it is 6 volt, 3 volt, okay, or even 1500 millivolt. So the output is entirely different from the input. Okay, so here this variation at the output is accomplished by chopping the input signal chopper, and the time duration. Okay, it is called as duty cycle. Okay, so that's all with this chopper. So let me give the definition. An input DC signal is turned into square wave by alternately grounding and connecting the input line. This square wave is amplified and then synchronously demodulated and filtered to give an amplified DC, and that avoids flicker noise. Okay, so What is the purpose of doing this one? Very important thing. First one is to amplify. Okay, either it can be high or it can be low. Okay, so it is in terms of electrical engineering, they will call as step up chopper and step down chopper. Okay, if the output voltage is high compared to the input, then that is called a step up chopper. When the output voltage is low compared to the inputs, then that is called a step down chopper. Okay, and that chopper, the another use is avoid the noises. Very important point is noises. Okay, and another very important point is it can be stored, because here we are converting into digital one. Okay, analog is converted into digital one. So here we can change a different term, that is data storage is possible, data manipulation is possible. Okay, so we can do different performance. Okay, we can do different performance, and we can go for modulation and demodulation also. Okay, so next we are going to discuss about the types. Okay, actually there are two different types of chopper. Okay, chopper amplifier. Chopper means sampling, as I said. An analog signal is sampled into their amplified voltage. There are two types. One is mechanical chopper, another one is non-mechanical chopper. Okay, so very important point. Please listen to the terminologies: mechanical chopper and non-mechanical chopper. Okay, mechanical in the sense this chopping is done using mechanical switch, and non-mechanical in the sense this chopping is done using non-mechanical switch. Okay, non-mechanical switch in the sense there won't be any physical activity, whereas in this mechanical chopper there is a physical activity. Okay, keep in mind, let me repeat once again, mechanical chopper, from the name itself you can able to understand that there is some action, physical action is taken, is to be happened in that chopper. Non-mechanical chopper, there won't be any physical action. Okay, so next we are going to discuss about the mechanical chopper. Okay, the chopper amplifier using a mechanical switch. Okay, here can anyone can you see the switch S1 over here? S1, this is the S1 switch. Okay, and this is the input voltage V1, and here is the output voltage V0, okay, or V0 also. Okay, so here the input is given to the amplifier, okay, operational amplifier. Okay, and after this time interval, when you close the switch, this input signal is short circuited, and that time it comes to 0. Okay, it comes to 0, and again the switch is opened and this input is fed into the amplifier, okay, as the rated value. Okay, and again when the switch is closed, it comes to 0. So opening and closing, opening and closing, opening and closing, that is on off, on off, on off. Okay, so this is called as mechanical chopper. Okay, so this switch is nothing but our domestic switch or some other mechanical switches, and the output, this is the amplifier. We can do step up amplification, and that is amplified over here, and we will be getting the maximum output. Okay, so this S1 is a mechanical switch. Repeating once again, this S1 is a mechanical switch. Okay, this S1 is a mechanical switch. Okay, this S1 is a mechanical switch. Okay, let me give one more example. You go to your home and you take one incandescent bulb, connect to the holder, and you switch on the bulb. Okay, and you just switch on and the bulb will get on. Switch off, the bulb will get off. On, bulb will glow. Off, bulb will switch off. Okay, if you do this continuously for 1 minute, okay, you can able to this manually. We can do this for 1 second. Okay, we can switch on for 1 second, we can switch off for another 1 second. Okay, so if you do this continuously, I am very frank, the bulb will looks like that it is glowing continuously. Okay, you cannot see visibly the turning off. Okay, so that is called as flickering. Anyhow, you are getting your continuous output, but you are continuously doing the on and off power. That is called as mechanical chopper. And next one is non-mechanical chopper. Okay, instead of switches, we will be having this LDR. Okay, LDR and bulb. Okay, so we all know very well that LDR is a light dependent resistor. When light falls on the LDR, its resistance is very high, and when the light falls, when the light is not allowed to on the LDR, its resistance will become low. Okay, so it is inversely proportional to the light. Okay, so here, so this turning and turn off can be done by switching on this bulb, neon bulb 1 and 2. Okay, so in the next class we will discuss about this non-mechanical chopper very in detail, and so that's all with the today's class. Thank you.